So in physics, we don't just want to study one-dimensional motion. We live in a three spatial dimensions world, and so we'd like to extend beyond one dimension. It turns out a lot of kinds of motions that we might be interested in that describe a lot of things, even in our three-dimensional world, can be studied in two dimensions if they occur in some plane. That is, so that's going to be our main focus. And it turns out if you understand some things about two-dimensional motion, it's not that hard to extend to three dimensions. But again, our focus is mainly going to be on two dimensions. So the first key concept there says that motion in two dimensions can be broken down into horizontal and vertical components. So let's say, for example, I'm just going to draw a horizontal line here that might represent some ground. It might have a few hills in it because I don't draw perfectly. And then let's say somebody here like launched an object and it's moving like a projectile. So it's going to move along some kind of curve over the ground. And that curve may be a little different depending on whether there's a lot of air resistance or not, but we're not going to worry about that for right now. So what does it mean with broken down into horizontal and vertical components? Now I think we saw an example in the last chapter already where I said like, hey, if I took that object and said it's right here along this trajectory that I've drawn, and what's its velocity going to be? Well, the answer that we gave was its velocity is going to point in a direction tangent to the trajectory along it's going, and I didn't really draw it perfectly there, but pretend that that's a tangential kind of looking velocity. But what we can do with that velocity, and this is going to kind of be part of the broader story of what you can do with something called a vector, and velocity is a vector, is you can break it into two components, kind of like a triangle like this. But we can also think of that at that particular instant, it turns out you can kind of put the components wherever you want. So I've redrawn this vertical component over by where the object is, because that's kind of like the way I might want to think about it, is to say this object has kind of like a speed, you could say, I don't know if that's quite the right way to say it, or a component of its velocity that is horizontal and a component that is vertical. And we can separate those two and model them as if they were completely independent of each other. And that's kind of what it means when we say we can break down this motion into both horizontal and vertical components. The second key concept, so again, I've drawn projectile motion here. That's what that refers to. So for projectile motion, the horizontal component of motion is inertial. Maybe I should have stated here for projectile motion in the absence of air resistance, but a lot of times in this class, we're going to have to just assume that. In other words, projectile motion is kind of referring to this specific type of motion, and it's generally tacitly assumed that we're ignoring air resistance. Of course, you can have projectile motion in reality with air resistance, but with air resistance, the horizontal component may not be inertial. So what does inertial mean? It means that this horizontal component, regardless of where you are, so like if I draw another spot over here and I say, okay, what's the horizontal component going to be? I should draw it as close as I can to be the same length as the one that I drew over here. In other words, that component maintains its value throughout the projectile motion. The other component, the vertical component, is going to change its value as this thing kind of goes higher and then lower through the projectile motion.